friends! I'm so excited to go along on this adventure with you today. First, we're going to hear all about all the different ways you can use STEM in your career from our friends at National Grid. Then we'll get our hands dirty with Mr. Dan as he walks us through a STEM activity.
Hi, I'm Mercedes Hanley, and I'm an electrical engineer working for National Grid, and here I have my friend.
Hi, I'm Haley Swanson. I'm also an electrical engineer at National Grid.
So, Haley, I know we've worked together for a few years, but how did you know you wanted to become an engineer?
It's kind of not really one thing. I loved puzzles when I was a kid. I always loved to put things together to figure out how everything pieced together. I loved playing with blocks. I loved science kits and building things. And that natural curiosity kind of just led me into a program in high school. It was a STEM program, and they broke down the different engineers, the mechanical engineers, electrical, every year was different. And it led me to electrical engineering. And I kind of learned that the electric grid is really just one giant puzzle, and it fascinated me. So I knew that electrical engineering was the way for me to go. What about for you?
I kind of had a similar background. My dad was an engineer, so I kind of grew up in the problem-solving household. My brothers were always pushing my buttons, so I had to prove that I was smarter. So with being surrounded with the constant problem-solving and fixing things around the house, this led to my curious mind to high school when I was also involved with some after-school STEM activities. And from there, I wanted to challenge myself in college, and I went for electrical engineering.
So on your way to becoming an engineer, what challenges did you face?
I would say the biggest obstacle I had as a young adult was that I was actually homeschooled. God bless my mother. She did a great job homeschooling 4 children, and she taught us in a unique way. And everybody learns differently, so I'm really thankful for the homeschooling experience. However, I was not necessarily accepted into all of the colleges because I did not have a strong academic background in their eyes. So I had to start at the community college, which is where I've learned some of my most valuable lessons for my life now. So after completing community college, I was able to then transfer to the University of Buffalo, where I was able to, graduate with my bachelor's degree. And by having a hard path of starting at the community college and transferring to UB, I've made some great connections along the way. And I believe that is one of the reasons I have such a great job now at National Grid.
That's awesome.
What were some challenges you experienced?
So for me, I think, and you know this as well, there's still kind of this preconceived notion and stigma around women being engineers. And I think we've proven that that's just not true. We certainly are capable of doing anything that a man can do in this field. But growing up, it kind of was challenging. I had some teachers who said maybe it wasn't the best idea for me to go into engineering because it was a man's field. Or, math wasn't my strongest subject, but I loved it. And I did not let my grades stop me from pursuing something that I really enjoyed. And it brought me here today, and I love my job and I love my career. So what exactly does an engineer do for people who don't know?
I would say the baseline of engineering is being given a problem and finding a solution. And for us, finding a solution that is going to work for our customers.
So it's kind of like us trying to incorporate more green energy into our system to keep our lights on, right?
Absolutely. It's finding the right place for it, where it's most protected, and how it fits into the puzzle, which is the power grid and keeping the lights on.
So that's like solar and wind and the panels that you might see off of the highway, right?
Absolutely.
So tell me about another problem that you had to solve.
A few years ago, we had a campground that kept getting bigger and bigger and adding more spaces for campers to come. And because there's so many campers, it was causing the surrounding house lights to start turning on and off. And if we kept letting that go, besides getting angry customers with their lights turning on and off, the station could have possibly caught on fire. So a solution to that was to build a mini station near the campground to give the campground more power and keep all the surrounding customers happy and with normal power.
So did it work?
Absolutely, and it's still being used today, actually.
That's awesome.
Yes. So tell me about a problem you've seen, Haley.
So there was one day when I worked in the underground cable department where we had a cable fault. So one of our underground wires, and there are tunnels that go all over the place,
Really?
especially in downtown, with cables that help to power your homes. And one of these cables had come apart, and it took one of the manhole covers and it threw it off during the middle of a very busy street during rush hour. So everyone's lights were out. We had to go and shut down the street, and we had to try and find underground, not being able to see anything, where this cable had come apart. So that was pretty rewarding once we found it, and the crews were able to fix it, and everyone's lights came back on. You could see all the lights turning back on as they fixed it. It was awesome.
Haley, what would you tell your 8-year-old self?
I would tell myself to not care so much about other people's opinions and what they think, that if you're interested in something, just keep doing it, and find people who will help you along the way, not people who will tell you that you can't do something. Like, if I had listened to what that teacher told me, that I couldn't do math and I couldn't be an engineer, I wouldn't be working in this job that I love and have a career and a life that I love. So it would be to keep doing what it is that you love and to not care so much about what other people have to say.
And just because you're a girl doesn't mean you can't do it.
Absolutely. I think you and I have proven that. You can do anything that you set your mind to, and you don't have to listen to what anybody else has to say about it.
That was so exciting. Now we're going to hear from Mr. Dan, who has a super STEM activity for us to follow along with.
Hi friends, I'm Mr. Dan from Explore More, the Ralph C. Wilson Jr. Children's Museum. And every third Saturday of the month, we host a science event called STEM Saturdays, powered by National Grid, where we fill the entire museum full of a bunch of different science experiments and activities. And today, I'm going to share a very special activity. First, I'm going to read a story, and then we're going to do a quick activity. The story we're reading today is Hidden Figures, the true story of 4 black women and the space race. It's written by Margot Lee Shetterly and illustrated by Laura Freeman. Dorothy Vaughan, Mary Jackson, Katherine Johnson, and Christine Darden were good at math, really good. In 1943, the United States was at war, World War II. Dorothy Vaughan wanted to serve her country by working for the National Advisory Committee for Aeronautics, the government agency that was designed to make airplanes. Having the best airplanes would help America win the war. Making airplanes fly faster and higher and safer meant doing lots of tests at the agency's Langley Laboratory in Hampton, Virginia. Tests meant numbers, numbers meant math, and math meant computers. Today we think of computers as machines, but in the 1940s, computers were actual people like Dorothy, Mary, Catherine, and Christine. Their job was to do math. Because Dorothy was black and a woman, some people thought it would be impossible for her to get a job as a computer. She lived in Virginia, a southern state where laws were segregated or kept apart. Black people and white people. They could not eat in the same restaurant. They could not drink from the same water fountains. They could not use the same restrooms. They couldn't attend the same schools. They couldn't play on the same sports teams. They couldn't sit next to each other in movie theaters. And they couldn't marry someone of a different race. But Dorothy didn't think it was impossible. She was good at math, really good. She knew she was the right person for the job, so she applied at the laboratory and they offered her a position as a computer. At work, blacks and whites were kept apart. The white computers worked in one building, and Dorothy and the other black computers worked in a different building, in their separate offices. Even though they worked on the same kinds of assignments, the black computers and white computers used separate bathrooms and ate in separate lunchrooms. America won the war in 1945, but Dorothy stayed on the job, still trying to make airplanes faster and safer. By 1951, the Americans and Russia were competing to see who could build the best planes. That meant more experiments and more numbers. Lots and lots of numbers. And more numbers meant the need for more computers. That's when Mary Jackson got a job as a computer at Langley. She worked in a group that tested model airplanes in wind tunnels. A wind tunnel was a machine like a huge metal box with a powerful fan attached. Mary put model airplanes in the wind tunnel and blasted them with air from the fan. This experiment helped her group improve their designs on the models before they built full-size airplanes. Mary wanted to become an engineer, but officials said it was impossible. Most of the engineers at the laboratory were men, and to become an engineer, Mary needed to take high-level math classes, but she wasn't allowed to go inside the white school where the classes were taught. But Mary was good at math, really good, and she refused to give up. She got permission to enter the school building and take math classes, and she earned great grades. Because she didn't give up, Mary Jackson became the first African-American female engineer at the laboratory. Katherine Johnson was good at math and always asked lots of questions. In 1953, she applied to the laboratory for a computer job and was placed on a team that tested actual airplanes while they're flying in the air. Their research was used to figure out ways to prevent future plane crashes. In one of her first projects, she learned how to analyze turbulence, or dangerous gusts of air. No one knows how many lives she may have saved. Katherine wanted to help the group prepare its research reports, so she asked if she could go to the meetings with other experts on the team. Her boss told her it was impossible. Women aren't allowed to attend the meetings, he said, but Katherine knew she was good at math as anyone else, maybe even better. So she asked him again, and again, and again. Katherine asked her boss so many times that he finally invited her to the meetings. Katherine was good at math, really good, but because she fought to be treated the same as men, she became the first woman in her group to sign her name on one of the group's reports. In the 1950s, the Langley Laboratory bought a machine computer that could do math faster than human computers. At first, these computers made mistakes. Dorothy learned how to program the machines so they got the right answers. She taught the women in her group how to program the computers too. In 1957, Russia launched a satellite known as Sputnik into orbit around the Earth. The United States started building satellites to explore space too. For years, the laboratory had used math to design airplanes. Now it would need math to create spaceships as well. The government decided to change the agency's name from the National Advisory Committee for Aeronautics to the National Aeronautics and Space Administration, also called NASA. In 1961, President John F. Kennedy told Congress, "I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth." A man on the moon, but the first step is getting a man on the moon was to send an astronaut around the Earth. NASA was going to need to hire even more space experts and more people who were good at math, really good. The people at the laboratory had to work together from morning to night to figure out how to send an astronaut, John Glenn, into space and bring him back home to Earth safely. Katherine Johnson knew she could use math to help. "Tell me where you want a spaceship to land, and I'll tell you where to launch it," Katherine told her boss. Katherine helped calculate the trajectories, or pathways, that rockets traveled through space. She had to plan Glenn's exact route from takeoff in Florida to splashdown in the Atlantic Ocean. There is no room for error. No one was better than Catherine at solving these tricky math problems. Days before his mission, John Glenn wanted Catherine to double-check the machine computer's trajectory calculations to make sure it hadn't made any mistakes. When Catherine said the numbers were correct, Glenn was ready to go. On February 20th, 1962, Glenn blasted off into space, circled the Earth, and made his way home safely. Meanwhile, laws began to change so that black and white students could go to school together. Blacks fought for the right to sit beside whites on buses and drink from the same water fountains. At the laboratory, black and white computers started working together in the same offices, eating at the same lunch tables, and using the same bathrooms. Black and white moviegoers could sit next to each other in the same theater. Across the country, people started to think about ways to bring equality to all Americans. Christine Darden was good at math, and she loved electronic computers. She started working at Langley in 1967. Christine wanted to become an engineer, and thanks to Dorothy, Mary, and Catherine, she knew it was possible. Eventually, she became an engineer for supersonic airplanes. That means planes moving faster than the speed of sound. But her first job was to help with NASA's mission to the moon. The people at the laboratory prepared for years to send astronauts to the moon, about 238,900 miles away from Earth. Finally, on July 20th, 1969, the world watched as 3 men arrived at the moon in their Apollo 11 spacecraft. That's one small step for man, one giant leap for mankind, said astronaut Neil Armstrong when he stepped onto the dusty surface. But it was a giant leap for Dorothy, Mary, Catherine, Christine, and all the other computers and engineers who worked at the laboratory over the years. The moon landing was a success from takeoff to splashdown, but there is no time to rest. Once NASA landed astronauts on the moon, the people at the laboratory began dreaming of sending humans to other planets such as Mars, Jupiter, and even Saturn. They started to imagine hyper-fast planes that could travel around the Earth at 7 times the speed of sound. The next adventure wouldn't be easy and would require lots of tests and lots more numbers. But Dorothy, Mary, Catherine, and Christine knew one thing. With hard work, perseverance, and a love for math, anything was possible. Wasn't that story amazing? So now what we're going to do, to remember this story, we're going to make our own rockets. For this activity, what you're going to need is tape, some construction paper. I have colored paper. Then you're going to need a straw and a bubble tea straw. You just want to make sure your straws fit into each other, just like this. So your straw is going to slide into your bubble tea straw, just like that. Then you're going to need a marker and scissors. So the first thing we're going to do, kind of like the people in our story, we're going to design a rocket. So I'm probably going to work with a sheet of red construction paper, and I'm going to draw out a simple rocket on here. So I'm going to start by drawing the bottom of a spaceship, and then I'll work my way to the top. I'll probably draw a little window to make sure the astronauts can see. Then I'm going to put a little engine on the back. So you can draw your rocket however you want. You can draw like a shooting star or even an astronaut. because what we'll do next is we're going to cut our shape out. So I'm going to take my scissors and I'm going to cut the outline of my rocket out. Cut my little engine. So this is my general shape for my rocket. So next, what we're going to do is we're going to grab our bubble tea straw. So this is the bigger straw, and I'm going to cut it out and I'm going to tape it onto the back of my rocket. I want to make sure the straw fits, so I'm just going to trim it just a little bit. I'll line it up with my rocket. Probably want it to run about like halfway or so. So just like this. And I'm going to need 2 pieces of tape. One piece of tape is going to cover the very top of our straw. So it's going to go just on top. And we're going to cover it just like this. We want to make sure the top is completely covered. Next, we'll take our piece of tape. And we're going to tape our straw down right on the back of our rocket. So it'll look just like this. Then comes the fun part. You want to make sure the area is clear from your friends and all your family. And then what you can do is you can do a quick countdown. So I like to start at 3 and then go down to 1. So what you're going to do is you're going to take your straw, slide it into your bubble tea straw, and then prepare to launch. So on the count of 3, 3, 2, 1, blast off. And what you're going to do is you're going to breathe into the straw and the rocket's going to shoot towards the ceiling. Just like that. Isn't that an uplifting project? Thanks for playing, my friends.
Well, friends, I don't know about you, but I sure learned a lot. I hope you had as much fun as I did. Keep learning and stay curious.